everybody. So this video is going to be about horizontal shift, which I left for last because it can be the weird one. So again, let's start off with our base functions. Let's take x squared and absolute value of x. And again, the ordered pairs are 0, 0, 1, 1, negative 1, 1. And this one also has the same set of ordered pairs in common, but the graphs are different. The x squared is u-shaped and the absolute value of x looks like a v. So I want to consider what happens when we add a value to the argument, which in other words, instead of f of x, we're looking at it as f of the quantity x plus 2. And we've talked about this in terms of substitution, that this whole quantity, the x plus 2, replaces the x. In other words, if I were to write this a little differently, I would think about it as this is a vacant space, and this vacant space is the same as this vacant space, and whatever's going on in here is getting squared. This is called the argument, okay? Now, what we're doing is we're taking, instead of x, we're thinking about it as shifting it x plus 2. So, and maybe I'm saying that poorly, but basically whatever your x was before, we're now adding two values or two units to it. And the effect is going to seem a little strange. So if we take 0 and we plug it in here, we have 0 plus 2, which is 2 squared. So now we have the ordered pair 0, 4. We used to have the ordered pair 0, 0. So that's a little strange. In all the stuff that we've done so far, the movements have seemed to fit. So let's take the x value 1 like we had here. We take 1 in and we've got 1 plus 2, that's 3. 3 squared is 9, so we have the ordered pair 1, 9. We take negative 1 and we put it here. We have negative 1 plus 2, so we get 1, and 1 squared is just 1. Now, I say, So I started to do a little bit of consideration. What happens if I take the argument, which is now x plus 2, and I set it equal to 0? So I take the argument x plus 2, set it equal to 0, and I solve for x. So I subtracted 2, and I have x is equal to negative 2. So what ends up happening is if we take negative 2 and we plug it in here, negative 2 plus 2 gets us 0, and 0 squared is 0. So negative 2, 0 is where 0, 0 gets shifted to. It actually moves opposite the sign. So if this is a positive 2, let me slide this down a little bit. So a positive 2 is a shift 2 units to the left. And I'll say this again in a bit, but if you did the argument x minus 2, this is f of x 2 units to the right. Notice the sign change. But I'll do another one. Let's consider the absolute value of x again, okay? And we're going to again do x plus 2 as our argument. So let's take the absolute value of x plus 2. Well, let's take that negative 2 and let's plug that in. Well, negative 2 plus 2 is 0, the absolute value of 0. So when x is negative 2, this is when your y is equal to 0. So if we travel back to the beginning, 0, 0 is actually getting slid over 2 units to the left to negative 2, 0. So negative 2, 0 is where the 0, 0 shifted to. Now, I'll try and sketch what I'm saying for the absolute values. And see if I can't move this over. There we go. So forgive me a little bit off kilter here. So here's 1, 1,